Hello everyone. In this video we will see how do we implement a queue using a linked list. This is also called as linked queue. And this linked queue or linked stack is much used with the tree data structure. Now let us see how do we implement it. Thank you. Now let us see how does a queue has to be implemented using a linked list. I am taking here the normal queue, not the double-ended queue. That means we only add the element at the rear end and delete the element from the front end of the queue. If it was an array implementation, the front end and rear end were initialized to what? -1 and -1. But in this case, we initialize the front to null as well as the rear to null. I'm not writing any structure over here, just the logic, then we'll see which structures, how do we do it. Suppose we want to implement it with the list. This is the node that I write it over here and I say 10 and we write null. Suppose this is the first node that is being added. This should become the front end of the queue and this should become the rear end of the queue if you are adding for the first time. Now if you are adding for the next time, suppose you write a node over here with P, this is 20 and this is null. Normally in queue where we add at the rear end of the queue. Therefore you say rear of next is equal to P and rear is equal to P. First you say rear arrow next is equal to P and rear is equal to P. Suppose you want to add one more element at the rear end of the queue. This is where you add it. Suppose this is 30 null and I write P over here. What is the algorithm that we have said? We have said rear arrow next is equal to P, and what is the next line that we have written? Rear is equal to P. Suppose we are adding not for first time. For first time this doesn't work. How to do? We will see later. Now rear arrow next. Now this is rear arrow next is equal to P, and what is the next line? Rear is equal to P. This becomes the rear end of the queue. This is how you add at the rear end of the queue. This is as good as the NQ because adding at the rear end of the queue is called as NQ. Now let us see how do we dequeue it from the front end of the queue. Now if you remove this 10, what should become the front end of the queue? 20 should become the front end of the queue. Therefore, first we will take one pointer over here. P is equal to front and you say front is equal to front arrow next or front is equal to P arrow next. And what do I write over here? Front is equal to P arrow next. This is where the front pointer comes and you are free to delete this P over here. And what do we write? We say free of P. Now again if I want to dequeue, suppose this is P over here. You say front is equal to P arrow next. This becomes the front end of the queue. Free P, that means this will go. Again if I want to dequeue it, front is equal to P arrow next. Now this is front is equal to P arrow next. Now this is P arrow next is null. Therefore the value of front will become null. Free P, that means this will go. And where does the rear is pointing to? Rear is pointing to the freed location, hence becomes a dangling pointer. Therefore you have to write if the value of front is equal null, then the value of rear should also become equal to what? Null. And this becomes a simple algorithm for dequeue and this becomes a simple algorithm for what? The NQ thing. Now let us see how do we do using structures before we write the code. I have already explained the structure representation of queue for both arrays and linked list. Let me reiterate for linked list again. Now what we have the collection of nodes. Suppose this is the linked list. This is the queue this is the front end and this is the rear end. What do we want to write? We will say struct queue. In case of array implementation, I needed array as well as the front end and the rear end. But here there is no array. Here there is only front and rear. Along with that there is a list. But the front and rear will represent the list over here. Therefore I need two pointers. One is the front and the second one is what? Rear. Now this front is pointing to what? A node. Therefore I write over here struct node. Rear is again pointing to a node. Therefore we write struct node over here. Now the question comes, how do we write struct node? You say struct node. There are two things over here. One, you can write any data type and data. And the second thing you say struct node star next. This is how it looks like. Now suppose I create a variable of type q and I say struct q. Now when you say struct q, the memory for this structure should be allocated. Now this is the memory which is being allocated. Suppose this is q. Q is of what type? Struct q. How many variables are there? There are two variables. One is front and one is rear. Both are what? Pointers. Therefore this is front, a pointer to node, and this is rear, the pointer to node. This is how the memory will look like. More about it I will say when we write the program. Now let us see how do we write the program for the queue implementation using the linked list. Thank you. Let us see how do we write the code. First thing is we need node. Let us say struct node. Data can be of any data type. Let us say of data type integer itself, int data, and the next thing is struct node star next. This is the node definition, and we need the queue. What do we write over here? I say struct queue, and this queue is made up of linked list, two pointers internally, the front and the rear. Therefore we say struct node star front. Why it is struct node? Just now I explained, and it is struct node star rear. This becomes the queue definition, and we write the main over here. What do we need in main? We need a queue. Therefore I write struct queue, and you can give any variable name p, q, r, s, t or something. Let us say queue itself. Now what will happen when you say struct q? The memory should be allocated. This is q. Let the address of this queue be say 0x1000. This queue is made up of struct queue. There are two things over here. What are the two things? It is star front, and the next thing is what? Star rear. And this queue has to be initialized. If it was array, we would have written -1. Now I cannot write -1 because it is a pointer, and if the pointer has to be empty, we write here what? Null and null. Null means not pointing anywhere, and it is empty. Therefore we will write one function called as init queue. Which queue we have to initialize it? This queue. And why we say ampersand queue? Because the state of the queue changes. See here, the value of front and rear was garbage and garbage. Now you are making it as what? Null and null. Now let us see how do we write the init queue function. Void, what is the function name? Init queue. Will the state of queue change? State of queue change means what? The value of front and rear will change. Yes. Therefore what do we write over here? We say struct queue star queue. Now what will happen whenever you say struct queue star queue? The scope of init queue function gets activated. There is one parameter. What is that parameter? That is star queue. Now what will happen? Ampersand q will be copied to q. What is ampersand q? 0x1000. Now from this I say q arrow front. Now what is q arrow front? Go to address 1000 and get front. What I want to store over here? I want to store null. Even you can write 0 because null is 0. You say null. Similarly q arrow rear should be equal to what? Null. Now 1000 arrow rear is equal to null. Now what user will interested in? User is interested always in the main program. Now in main program, if I just see this, struct q, I don't know how the structure is written. Will I be able to know that it is implemented with arrays or with implemented using list? Do I come to know? I do not come to know. That is what the abstract data type is. That means you should not know whether Q is implemented with arrays or Q is implemented with what? List. That is abstract data type, and you should strictly follow this. Yes, it becomes very difficult for you to learn C++ and Java going further. That's your choice. How you want to write over there. Therefore, we say struct QQ. I never know, if I don't know the structure definition over here, I never know whether it is array or whether it is using the list representation. Now, I call the function initQ. The same function I have written while implemented using arrays. Do I know, again when I call initQ function, I don't know how initQ is written or not. Internal details the user doesn't care. User only cares how to call the function, how to create the queue, that's all. Now when I say initQ of ampersand q, will the user know that it is array or whether it is list if I have given only this? No, because the same function we have written whether it is array or whether it is list. Therefore, q is called as an what? Abstract data type. Now let's say while 1 we will write some options. The first option that we will write is NQ, second option is DQ, third option is get front, fourth is display, 5 is size, and 6 is what? Exit. You read the choice, then we say switch choice. We write one by one cases over here. Let's see how does it is going to be done. Before I do this, this is not Scratch, this is just to explain I've done this. Please write down this code, then I will erase this and we will see one by one cases over there. Thank you. Now let us see the first case, that is NQ. I write over here case 1 NQ. Now to NQ we need an element. Let us say read some element E, and we will write one function called as NQ. Where do we want to NQ in this queue? Will the state of the queue change? Yes, the value of front and rear from null will become something else. Why it becomes, I will explain. Hence we say ampersand q comma E, and I write break over here. Let us write the NQ function. We say void, what is the function name? NQ. What is the first parameter? Ampersand q. Therefore it is struct q star q. And what is the second parameter? Integer E. Now this we are implementing using what? The linked list. Now linked list is the collection of nodes. That means I need a node over here. If I need a node, I have to create a node. How do we create a node? I say struct node star p is equal to struct node star malloc of size of struct node. Now what will happen? A node will be created. Now this is where p is. Suppose there was no memory to create this node. Suppose there was no memory. If there is no memory remain to create a node, what does malloc function will return? Malloc will return null. Therefore, we write over here, if the value of p is equal null, there is no memory there which is used to create the node. Can we create a queue out of it? It's not possible. Therefore, I write over here printf memory full. And since memory is full, what do? We return. If suppose the value of p is null, no memory is there. If the value of p is not null, suppose this is the memory created, this is p, let the address of this be say 30,000. Let the address of this be say 30,000. Now p is 30,000 is equal null? No. That means you can add some data over here. How do you add data over here? You say p arrow data is equal to e. Whatever the e, suppose e is 10, I want to NQ 10 onto the queue. And what should be p arrow next? It should be null, because you are adding at the rear end of the queue. You are always adding at the end. Since you are always adding at end, p arrow next should be equal to what? Null. I say p arrow next is equal to null. Now, are we adding this node for the first time? Yes, I am adding this node for the first time. How do we know that I am adding this node for the first time? Because the value of front and the value of rear is what? Null. Therefore, we write over here, if q arrow rear is equal null, even you can write q arrow front equal null. That means we are adding for the first time. And if we are adding for the first time, this should become the front end and this should become the rear end. Hence we write q arrow rear is equal to p, and what is the next line that I am going to write? Q arrow front is equal to p. Now what is q arrow rear? This is q arrow rear is equal to p. What is p? 30,000 that we have assumed, and q arrow front is equal to p. What is that 30,000 that we have assumed? That means this is front end and this is the rear end of the queue. As of now, we assume that this is being done, closing bracket is taken as return, and this is being added at the rear end of the queue. Now suppose I say NQ 45. Now what will happen? A node will be created. Now this is P. Let the address of this be say 40,000. P equal null. No. P arrow data is equal to E. Let us say 45. P arrow next is equal to null. This is null. Is Q arrow rear equal to null? No, Q arrow rear is not null. That means I am not adding for the first time. And if I am not adding for the first time, I should add at the rear end of the queue. Therefore, we write over here else. And what do I write over here? I say rear arrow next is equal to P. Rear arrow next is equal to what? P. But the compiler will report error because is there any variable called as rear over here? See, there is no variable called as rear. This rear is embedded in what? Q. Therefore, we have to write Q arrow rear arrow next is equal to P. Why Q arrow rear? Because Q is a pointer. Q arrow rear means what? 30,000. This complete node of next is equal to P. And what should become the rear pointer now? P should become the rear pointer. Hence we say Q arrow rear is equal to P. Now this becomes the rear end of the Q, and you see the 45 is added at the rear end of the Q. Suppose if I say in Q 100, P is equal to get node, this is P is equal to get node, this is the get node function, P arrow data is E, this is 100, P arrow next is equal to null. Is Q arrow rear equal to null? No, else should be executed. Q arrow rear is this complete node of next, this is of next is equal to P, and you say Q arrow rear is equal to P. Suppose the address of this is 50,000, what does rear will become? Rear will become 50,000 over here, and you see that the node is being added at the rear end of the Q. This is the very simple function of the rear end. How do we add it? We create the node, you add the data. If you are adding for the first time, the value of rear or the value of front will be null. Therefore, the node itself should be rear and front. Why we say Q arrow rear? Because if you just write rear or if you just write front, there is no variable called as rear, neither there is variable called as front, but they are embedded in Q. Now, if you are not adding for the first time, that means you are adding at the rear end of the Q. Suppose this is rear and suppose this is P. How do you add it? You say rear arrow next is P. Why you should write Q over here? Because it is embedded in P, and rear should become equal to P because this becomes the rear end of the Q. Next, let us see how do we write the DQ function. Very simple. Now let us write the function DQ. Now before you DQ, you have to check if the Q is empty or not, else you cannot do it. Therefore we say if is empty of Q, then printf Q is empty. Now how do we know that the Q is empty? If the value of front is null or the value of rear is null. Null means there is nothing over here. Hence we write over here int, what is the function name? Is empty. What is the first parameter? Ampersand Q. We say const over here because the state of the Q does not change. Const struct Q star Q. And how do we know that the Q is empty? If the value of front or the value of rear is null. Hence we say if Q arrow front is equal null, and I write return over here. Now what is Q arrow front? It is 30,000. Is 30,000 equal null is false. That means Q is not empty. If Q is not empty, I can DQ it. Now if I DQ, what do I get? I will get 10. That 10 has to be stored in some variable. We say E is equal to DQ of ampersand Q, and we write printf the DQ'd element is E. That marks the end of the case 2. Now what is the return type of DQ? It is integer. We say DQ. Now you don't write const over here because the state of the Q changes. Therefore we just say struct Q star Q. Now before we delete this, I need to store this variable, and front should go ahead. Now if front goes ahead, it is a single linked list. I cannot come back and delete this. Therefore we take one pointer P over here, and P is pointing to what? Node. Therefore I say struct node star P is equal to. Where it is pointing to? It is pointing to front end of the Q. Now is there any variable called as front? No. That front is embedded in Q. Therefore we say Q arrow front, P is equal Q arrow front. Now front should move one step ahead. Therefore I say Q arrow front is equal to P arrow next. Now what is P arrow next? This is P arrow next. Therefore the front comes over here. Now I can say free P. Before I say free P, 10 has to be stored in some variable. Therefore we write int E is equal to P arrow data. Now the value of E will be 10. You might say free P Now what will happen when we say free P? This will be gone. The answer is stored in E, and what do we write over here? We say return E. That means 10 is the front end of the queue which is deleted. Suppose I want to dequeue again. E is empty. Is Q arrow front equal null? No. You say P is equal to Q arrow front. P is equal to Q arrow front. The next line is front is equal to P arrow next. This is front is equal to P arrow next. This becomes the front end of the queue. E is P arrow data. E becomes 45. Free P. That means this will go return E, and 45 will be returned back. Now if I say again dequeue from the front end of the queue, E is empty. Q arrow front is 50,000 equal null. No. You say P is equal to Q arrow front. Now this becomes P. What is the next line? Front is equal to P arrow next. Now this is front. E is P arrow next. What is P arrow next? Null. Therefore the value of front becomes null. E is P arrow data. E becomes 100. Free P. This will go. Now where rear is pointing to? It is pointing to free location. That means if the value of front is null, rear should also become null. That is what we write. If Q arrow front is equal null, then what should be Q arrow rear? Q arrow rear should be equal to null. Hence the value of rear will also become null, and you say return E. Suppose I want to dequeue again. Q arrow front. What is the value of front? Null. Null equal null is true. It returns 1 and it says the queue is empty. This is how we delete an element from the front end of the queue. Now let us see how do we write the get front function and the display function. Thank you. Now let us see how do we get the front end of the queue. What is the front end of the queue? 10. Now if the queue is empty, we cannot get the front end of the queue. Therefore again we write over here, if is empty of ampersand q, printf q empty. Now q arrow front, is it equal null? No, that means the queue is not empty. Therefore you can get the front end of the queue. Now when you get the front end of the queue, you get 10 as answer. That 10 has to be stored in some variable. We say E is equal to get front of ampersand q, and you say print E, that is the front end of the queue, and this will end the case 3. Now what is the return type? Return type is integer. What is the function name? The function name is get front. Will the state of the queue change? No, therefore it should be const. And what do we write over here? Struct q star q. Now what is the front end of the queue? You say q arrow front. Now when you write q arrow front, this complete node is taken. And in this complete node there are two things. What is the first thing? Data. And what is the second thing? Next. And what I am interested in? I am interested in data. You say q arrow front arrow data. Q arrow front. I mean brackets are not necessary, just to make it easily understandable. Q arrow front is this complete node. Arrow data is 10 and I need 10 as answer. Therefore you say return, and the front end of the queue is 10. That will be printed. And the next function that we are going to write is what? Display. That is case 4. What do we say? I write one function called as display ampersand q break, because I want to display this queue. What do we write over here? We say void display. Will the state of the queue change? No. Therefore it is const struct q star q. Now when I want to display, what is the queue over here? 10, 20, 30 from front end till the rear end of the queue. Therefore let us take one pointer p over here. Hence you say struct node star p is equal to q arrow front. Now this is q arrow front, it is, and p is pointing over here. Now this I have to display 10, 20, 30 till it becomes null. It is same as display of the linked list. Hence we say while p not equal to null, and what do I write over here? Printf p arrow data. Now what is p arrow data? 10 is displayed. P has to go to next node, and then what do we write? P equal p arrow next. This is where p will come. Go back, p not equal to null. Print p arrow data 20. P equal p arrow next. Again go back, p not equal to null. Print p arrow data 30. P equal p arrow next. The value of p becomes null. Null not equal null is false. It comes out, and you see that the queue is being displayed. And what is the last case over here? It is size. Case 5, we will write one function called as q size ampersand q, and it will give the number of elements, and let us store it in some variable called as m, and you print the value of m. Now what is queue size? The number of nodes, that is the length of the list. And how do you find the length of the list? Instead of printing over here, what do we write? We say count plus plus. We know how to find the length of the list. I'm not going to write. You write the queue size function yourself, and the next case is exit. This will complete how do we implement a queue using a linked list. And in the next video we will see how do we implement a priority queue, and then we will see what is a priority queue, and then implement the priority queue using the linked list, and I will say why linked list is preferred over the array implementation in priority queue.